Hey, welcome to the Fresh Codeman. Today we will be looking at the data partitioning, how to partition the data. So we all know whenever we create a backend services or any kind of system, we store some data in the database. But suppose when data get huge, what you need to do? If you take an example of YouTube, so on daily basis there are tons of videos got uploaded on the YouTube, how they are managing the data of their own because they cannot have a single DB, and in that single DB they are having all of the videos or all the data inside it. So they use the data partitioning tools or techniques that we will discuss today. Okay, so let's start. So today we will be looking at these particular things, data partitioning definition part. We will be going to define data partitioning, partition, and the partition key and shard. Let's start with the data partitioning. What is the data partitioning? We all know, suppose we have this database, okay, and in this database, we have the storage of suppose 10,000 people. So I details. Okay, so it has the storage of 10,000 people, 10K profiles. But when it goes and now your application got hit, and now the new users going to add into this single database, or maybe we can take some other like normal example in which you have a single database and you have a e-commerce system in which you have to have some product details whichever you are going to sell, and to order detail that orders you make to sell it, and the profiles for the users, right? Or and some other tokens for session tokens and or history, and all of them you are storing in the into this single database. But what happen if slowly what happens if slowly you realize the profiles or users get increasing exponentially? This database is not suffice. In that case, what we will do, we partition the database. Partitioning is we create some we so we subdivide or we break this database into multiple databases, so we can just duplicate it. Okay, where is the duplicate? Okay, so you create a one more database in which you store half of the data. So half data is here, half data is here. So both of them are called as partition. So if in the nutshell, if you say data partition is a technique used in the distributed system design to divide the big chunk of the data into smaller, manageable, and processable data sets. And those data sets called as partition. Okay, so now we are saying we divide this data in half and half. But how you are dividing it? That's the one point, right? So you will be using some kind of attributes or definition or rules to divide the data. Maybe you are saying ki, okay, uh, I will I will whatever the profiles we have already created, the old one, for them we will use the old database, and for the new one we will create a new one. If new profiles come into the picture, we will use the new database, right? That is the rule we are using to divide the data. That is called as partition key. Yeah. Generally, this partition key can be a range, it can be a date, it can be some other attributes of the database, it can be anything. So that is the partition key. Partition key. And if you're for looking for the definition, then the definition of the partition key is It is a attribute, rule, or some definition that used to used to partition the database. That is called partition key. Okay, and then let's move to the shard. Okay, we already know the partition. What is the partition? And the partition and shard both are the same, but shard, we call the partition as a shard on only on horizontal partitioning. We will see what are the horizontal partitioning and vertical partitioning. That's not the problem, but we will see. Okay. Okay, so partition shard is nothing but just a partition. Let's move to the type of partitioning. Type of partitioning. There are generally two types of partitioning. One is one is horizontal. I mean, three type of partitioning. Horizontal partitioning. And what is the horizontal partitioning? So earlier what we did is we divided our data based on a rule that whatever the old data is present, that will be inside one. Suppose that is in the this database and other one is in this database. But maybe you might say, and you say, okay, that is the, we are dividing the data based on the creation date. So our partition key was creation date, right? And the, if you look at the tables, if you look at the tables of all of them, suppose let's take an example of the users. Okay, so users table we are taking an example. What will happen, right? If there is a Ram and there is a Shyam, and if Ram was created uh, before before, suppose we are saying कि uh, 1/1/2025 के पहले वाला डेटा will goes here, उसके बाद वाला डेटा will goes here. So before 1/1/125, so Ram will be stored in here and Shyam will be stored in here. That is the horizontal partitioning actually. So when you divide the data in a subset of the rows to different databases or different partitions, that is called as horizontal partitioning. And where we use it, the one more good example for that is generally um, like streaming services. If you take an example of stream, or if you take an example of Amazon, they use this horizontal partitioning for the for the storing the data location wise. So for suppose for India, they store the data in 1 DB, and then for America, they store the data in the some other DB. And what is the problem with it, by the way? There is one problem, interesting problem with it is, if you are dividing the data based on the some uh, partition key, and if you don't choose it wisely, like suppose they chose it based on the geographical data, geography, so they assumed the partition key is geographical ID, right? So partition key is geographical ID, GID, ठीक है, geo ID. Then because in India people are a lot more than US, so this database going to be very heavy, have traffic heavy, because all Indians will be targeting through this particular database, all the requests will going to this particular database. Then it will be because in India density is great, so it will feel overhead than this one, okay, than the American one. So that is the problem with it. So we can go to some other partitioning systems. Let's move to the other one. That is the vertical partitioning. Okay, horizontal is done. Let's move to the vertical partitioning. Second one is vertical partitioning. Vertical partitioning. Vertical partitioning, what happens into it? Suppose you have a table like similarly earlier we were having, and here is the RAM. Okay, let me small then the RAM. Shyam. Okay, and here you have for this RAM's information you have some order IDs, order details, payment details, name, and address, and here you have the ID. What you can do instead of dividing the data row wise, you can divide the data column wise also. So you think, okay, what we can do, we don't need order and payment right now. Whenever they request it, we can ask it from the some other database. So what we will do, we will store order and payment detail in one partition and the name, address, and ID in the some other partition. Name and address in some other partition. So this way we are dividing a data based on the column wise, and here is the partition keys are like, okay, so for dividing this particular table we are saying we are having a rule that says the orders and payments will goes to this one, that is our partition key. And what are the drawbacks with it? The drawbacks with it is, suppose if you don't choose the partition key wisely, the same thing goes to this one also. Then what happens? It might be possibility that some of the column you chose, those reaches to one database, and those are heavy traffic, like people are looking for the orders daily on daily basis, but they are not looking for their profile pictures or not clicking on their profile, so they don't need this, so they don't, this name and address partition won't be that heavy traffic at all. So the performance of the both DBs will be different, and the first DB where we have the order and order and the some other details, payment details, it will be triggered most of the time, and it might cause become a cause of the failure and don't improve your system at all, right? And there is one more other thing, if your issue with vertical partitioning. The other one is, if you wisely not consider the keys and you mixed up the keys. Suppose what you did, suppose you have name, address, and surname, and mistakenly you put the name in one partition, partition one, and surname in the second partition. So whenever someone asking for their name, you will be looking, you will be doing cross partition query. Okay, cross partition query. So you have to make a query for both of them. That is the extra and nonsense things to do, because now your system will making multiple queries to get this uh, and get the data, and that will increase your latency time. Okay, now let's move to, now we, okay, now third thing, there is a third thing, that is the hybrid partitioning. Okay, okay, hybrid. In hybrid partitioning, what happens is, you are utilizing the benefit of both of them. Suppose you can take an example of streaming services or some big corporate where you are firstly you are dividing or making partition based on the geolocations, and then whatever the data you are getting, and then you are using that was the horizontal partition, right? Horizontal partition. Then you are dividing it by vertical partitioning, such that like you are separating the name, address, and the payment order in separate partitions. So this way you are utilizing the benefit of both the partition techniques or types. Let's move to the next thing. That is the sharding technique. So horizontal partitioning is called as sharding, by the way. So that's why for horizontal partitioning, the partition is called as shard. Now we will be looking at the sharding techniques. Okay, so up until now we know that whenever you are trying to do partition by horizontally, you will be dividing the rows, the set of rows in separate partition based on the partition key. That's okay. But what are the methods to select the partition key? Or yeah, what are the schemes to do the horizontal partitioning? Main important thing. What are the schemes to do the horizontal partition? To do the horizontal partitioning, we use multiple strategies or multiple schemes. One of them is we say range based, range based, range based partition. What we do in the range based, we pick a one of them. Uh, Suppose we picked the ID, and now what we will say is the rule of partition key will become this like this. Okay, from this point to this point, we will be having partition 1. From this point to this point, we'll be have a partition 2, 1, 2, and then 3, and that's how they will be dividing the partitions. And it can be ID. Suppose you have the ID in a numeric values, then from ID 1 to 1 lakh, you have partition 1 and partition 1, and then 1 lakh to 1 lakh to 2 lakh maybe, then you have partition 2. So this way you can divide your partitions. What is the benefit of it? The benefit of it is quite easy, and your system can easily access the partition based on the ID, and your system not need to process more of the data in a way, right? And then we have another way of scheme, that is hash based partitioning. Hash based partitioning. So in the hash based partitioning, what happens is your key, this is used when you have a key, and that key can be hashed in multiple ways, right? And you don't know how to partition it by using range based. You don't have clear definition in your mind. So then you can use the hash based partitioning. What you do, what happen in this partitioning is, it takes your partitioning key. Okay, it takes your partitioning key, and then a hash function use this key. Suppose we have this black box that is called a hash function, and then it creates a new key or some number, and that number is going to be associated with the partition number. Okay, so and based on this partition key, you send your data to the respective partition, and that's how we do the partitioning. And this is good because you don't have to remember any kind of rule. This hash function automatically creates a partition number, and you can automatically go and look at the partitions whichever you want to look. Okay, and then partition key can be hashed by this manner. And if suppose in some cases it have some of the challenges with it. The main challenge is, suppose you are trying to manage your data, and somehow the your data is crashed, then you have to make some backup or something. Or maybe what happens, users got increased, and then you are facing heavy traffic and you want to scale your system. In that case, if you have to scale your system, then you will be providing more partitions to the system, and then these more partition will cause an issue because you have to rehash the whole system, and this rehashing is very time consuming, and labor consuming, yeah, and it is not performant at all. So here is the problem in this hash-based pattern, hash-based partitioning. Then we have one more partitioning technique that is called as directory-based partitioning. Directory-based partitioning. Based partitioning. In the directory-based partitioning, what we do is we maintain a directory which have the partition key value, and that is hashed to the partition number or partition, yeah, partition number you can say. And suppose A here, this is 1. Let me make this one A and 1, B and 1, and B and 1, and C and 2, and D and 3. So it is saying the data related to A will be stored in the partition 1, data B, C, and all of them related to the store in the partition B, and then data related to C will be stored in partition 2, and then D will store in the partition 3. What is the benefit of this directory? The benefit of this is if you are scaling your data, or maybe somehow your partition got crashed, what you can do, you introduce new partition and you just change this directory's name, then your whole data will be able, you can able to fetch the data. Okay, and then it helps you to make a backup, and you don't need to have the any kind of rehashing. Okay, cool. Let's move to the next one. Next kind of, that is geolocation based partitioning. What it means? It's pretty simple. You choose a location in a in your distributed system. You select the location. Based on that location, you create the partitions. This works for the big giant companies where they have lot of data, and then they like it can work for the streaming services, and for them you have to have a data in a location wise, right? So it's pretty simple. Then you have a dynamic dynamic partitioning, dynamic sharding you might say, because horizontal partitioning is sharding. Okay. Dynamic sharding is, it based on your key, it automatically decide the number of partition. It can automatically scale the partition if needed. So that happens in this dynamically. Yeah, it's pretty cool. If you have a like varying traffic, or suppose you feel it will be a fault tolerant for the sudden spikes, and for those, all for those cases, dynamic sharding is good. And then the final one is the hybrid. Hybrid is the similarly. We look for the many advantage of different sharding techniques, but you can utilize all of them in this hybrid using the hybrid sharding. Okay, so what happens? You might be thinking, okay, I will use a geo location based sharding, plus I will be using a directory based sharding. Yeah, this is a hybrid. Or maybe you are thinking, I will be using a ranged based sharding plus hash based sharding. Okay, that is possibility. So you can utilize all the sharding techniques in a single way. Okay, let's go to the next thing. What is missing now? So benefit of the partitioning. Yeah, what are the benefits of the partitioning? सबसे पहला biggest one. If you are dividing your data, then performance performance of your system will going to be increased. How? So if you divide your data, then whenever some request came to your backend, then it don't have to process the data that is not necessary for that particular request, and it only look for the specific partition or that in which the data is stored, and then it will get it right. So the performance is going to be increased because the data the processed data is less. Okay, processed data going to be less, so performance going to be increased. Then uh, data isolation. Yeah, data isolation. What is data isolation? Data isolation means when you have a data, suppose some attacker attacking on your system and your backend got attacked, and then the attacker is looking for just an specific data, then only that particular partition will going to be affected. That is the case one. The another case is due to some unknown caveat or maybe some other things, the partition got crashed, so other partition will be saved because they are not connected to it. So those are isolated, and that's why they are secure. So data isolation is there. The third case, maybe, okay, yeah, right, that's it. And then we can say the third important part is security. Security, yeah. And how can it improve the security? So what you can do is when you are partitioning the system or partitioning your database or your data, then you can partition in a such a way that the one partition in which you have the sensitive data, you protect or add some more firewalls or more security policies on that. But the another ones you can leave it as it is. So because you are confident enough कि this data is not that useful or that severe for the company. So yeah, so that's how you can improve the security part also, because now you only have to secure only one or two partitions in which your severe data is there. Okay, then what are the other, the performance is done, availability, yeah, or fault tolerance maybe. Yes, that is a good one. Fault tolerant and availability, yeah, that both are same, looks like same to me. So we are saying it makes system available. How? So it makes a system available, because if there is only single DB, then all the traffic going to be went to that single DB, and it might have the situation in which is going to be crash and your system, whole system going to be unavailable. So, but if you have the different partition, in that case, your system going to be available even though one or two partition got crashed. So that makes your system available and reliable, both of them. Okay, so your system become more reliable than earlier. And what are the things we done? Performance, organ, security, availability, reliability, and then okay, now I don't know what are the things remaining. I'm looking at my notes. Okay, here we have the better resource utilization. We look for that. Simplified data management, storage efficiency, parallel processing, data isolation done, load balancing is done. Load balancing, yeah, load balancing also can be done. Enhanced scalability, yeah, scalability is done. That is the availability and all of that, right? And then improved data security, that is done. Fast data recovery, that is done. Okay, now we can look for the parallel processing, storage efficiency, and the simplified data management. Okay, and the one is parallel processing. in parallel processing, because you have multiple partitions, so for all of them you can do parallelly process your data, such so you can get the response as quickly as possible. So it improves your latency ultimately. Okay. And then you have uh, storage efficiency. Similar ways, because you can process the data faster ways, so it improves the efficiency of the storage. Simple. And then, okay, what are the remaining one? Remaining one is simplified data management. Yeah, that is important. It improves the data management. How? So there is definitely one person who is looking at the all data, and if something goes wrong with it, they will be the responsible person for that particular loss of data. So to manage that particular thing, maybe they do some kind of backup, maybe they just rehash the whole system or do some things. So those processes going to be easy for the manager, because now the partitions are small, so it will take less time, right? Yeah, less time. So that's why data management is efficient now. Improve data security, that is then faster data recovery. Okay, cool. So now we are done with this. Let's move to the last topic for today, that is challenges of the data partitioning. Okay, the biggest challenge that comes to my mind is uh, if you are uh, mm, yeah, cross partition query. So if you created or you chose your partition key in such a way, or maybe you made a application that needs to fetch the all kind of data in a one query, then it needs to query. Suppose this is our backend, and here we have our back. Here we have the data, the partition one and partition two. If it is going to query all these partition, then the latency going to be increased. Instead of reducing the performance, increasing the performance, it is reducing it. So if you don't do the partitioning in a sensible way, then your system, instead of better performance, it might just destroy the performance of your system. Yeah, so that is the bigger issue. Then next one is the selection of partition key. Selection of partition key. Okay, selection of partition key. Why it is problem? Because if you choose the wrong partition key, then it might cause this cross partition query. It might cause imbalanced data or uneven data storage in the different partition. It might cause some other issues also. So the selection of partition key is very important for the partitioning or sharding. And the next one is skew data. Database or partitions, skewed partitions, skewed data. If you choose a partition key in a such a way that your partitions are going become uneven, and then somehow some data, okay, uneven, and that can happen in two ways. One way is if partition one and partition two, one partition have more data or this have less data, the amount of that, okay, amount. And the another way of happening this skew data is this the data amount is same, but the active data on the one is higher, or requested data requested data on partition 1 is high instead of partition 2. So that might happen. That cause this skewed data. Okay, we need to take care of it. And then other part, it makes your system complex. Okay, whole system I'm talking about, not the single one thing. So system in a way become complex. Now you have to take care of all the architecture, new architecture that is more complex than the older one, because now you have multiple partitions and you need to decide which partition to use when. So you have to have create some kind of intermediary services. Those will decide which partition to use for the backend or some applications, right? So your system become more complex. Okay, then next one. Yeah, now I forgot. Challenges. So complexity is done, data skew is done, partition key selection is done, cross partition queries happens, data migration, partition maintenance, and cost. Okay, so data migration. So whenever you are creating a partitions, so it will create a overhead of migrating data, overhead of migrating data. Okay, so that is a big problem, overhead of migration, because you will be migrating all data into small partitions, and that will not going to is be that much easy. So that is a big issue with it. And then the next one is, I again forgot it. Let me see. Partition maintenance and cost. And the next one is the partition maintenance. Partition maintenance is because now you have multiple partitions. So the manager have to look for all the partition if they grows that big, and now he have to manage all of them instead of managing one. So like it might be backing up the data, it might be monitoring the data, or anything it can be. So maintenance it quite big. Like earlier I told you the benefit of maintenance, now I'm telling you the drawbacks of maintenance. So yeah, the benefit of is there and drawbacks also are there. And then the cost. And then partitioning the data definitely going to increase the cost, and you have to consider based on your system. Okay, so here is this होता है खत्म. And if you want to look at the links, whatever the notes I made, you can go into the description and see them. And thank you. Bye bye.